Hello everyone, and welcome to The Current, the North Central Region Water Network's Speed Networking webinar series. The North Central Region Water Network is an extension-led collaboration among land-grant universities in 12 upper Midwestern states, working to build capacity for effective decision-making on water-related issues. My name is Rebecca Power. I'm Director of the North Central Region Water Network and your moderator for this webinar. The purpose of the Current is to increase your access to university extension programming and research that we hope will be useful to you in your own work. The format of this webinar will be 3 10-minute presentations with questions and discussion at the end. All webinars are archived on the North Central Region Water Network website at northcentralwater.org. Our topic today is application of cover crops in the Midwestern U.S. And I just want to thank Dean Baas at Michigan State University for organizing the webinar and being one of our speakers. Our other speakers are Tom Kaspar at USDA Agricultural Research Service and Matt Ruark at the University of Wisconsin. And we'll tell you a little bit more about them in a minute. This webinar is the 9th in our series, and I just want to give a quick plug for the next one, which is on July 15th at 2 p.m. Central, 3 p.m. Eastern, same times. And the topic will be various dimensions of harmful algal blooms, all the way from causes to some things that we need to know to keep ourselves safe when they happen. Here are some tips for a successful experience in this webinar. So most of us won't be talking, so you don't need to worry about the headset too much. But we will be asking you to submit your questions for presenters via the chat box, which should show up in the lower left-hand portion of your screen. And we'll use those questions at the end of the 3 10-minute presentations. If you do feel like you need to ask for interaction with the presenters or need to clarify a question, please use the hand icon, which should be around the middle of the left-hand side of your screen, and then you will need to press the talk button, which has a little microphone icon, and this is further up on the left-hand side of your screen. Okay, so here's a little bit more about today's presenters. Let's see if we can keep on the same slide there. Dean Baas is going to be talking about the Midwest Cover Crop Council. Tom Kaspar is going to be talking about effects of cover crops on nitrogen and tile drainage, and Matt Ruark is going to be talking about cover crops after fall manure application. So Dean, why don't you go ahead and get us started?
Hi everyone. Thank you, Rebecca. I'm Dean Baas with Michigan State University Extension, and I'm an executive committee member of the Midwest Cover Crops Council. I'm pleased to have this opportunity to tell you about the council, how it might be a resource to network members, and I'm going to offer my views on why I believe this is a regional collaboration that works. So getting right into it, what is the Midwest Cover Crop Council? We're a regional network of diverse cover crop resources. We like to call ourselves a loose collaboration. We're not a nonprofit. We are pretty much a network of people that work together. We have some structure, and we are working towards making some changes to the leadership that I will talk about at the end as I talk about where we're headed in the future. We currently don't have a home or a distributed network. It's led and managed basically through individuals throughout the region. That has been a little bit of a problem because people don't really know where to find us. That's something we're also working on in the future. We're currently a volunteer organization. We do not have sustained funds to operate the Midwest Cover Crop Council. We kind of pieced it together, and the people who are involved are operating pretty much on a volunteer basis, and but they do that because they see advantages in being part of the organization. We're a group that researches, consolidates, and distributes cover crop information through our members, our website, our listserv, meetings, and products. Why is there a Midwest Cover Crop Council? Well, the goal is to facilitate widespread adoption of cover crops throughout the Midwest to improve ecological, economic, and social sustainability. The people who make up the Cover Crop Council are a diverse group. We have people from academia, production agriculture, non-governmental organizations, commodity interests, the private sector, as well as representatives from federal, state, and provincial agencies. It's a very diverse group, and that is really one of our strengths. You can see the map there on the right. The Midwest Cover Crop Council area is the North Central region states and the province of Ontario. I guess that would make us a regional international collaboration. At this point, I'd like to put a brief plug in for our colleagues in Canada. Those folks are working with a lot of the same issues that we have. Their farmers are dealing with the same problems, and they create a lot of really good material, educational material, put on a lot of good programs. So I would like to encourage everybody to think of our colleagues in Canada when you're looking for collaborations and looking for information. The Midwest Cover Crop Council collaborates to address soil, water, air, and agricultural quality concerns in the Great Lakes and the Mississippi River Basin. This is a list of the collaborators and partnerships, and I'm not going to go through all of them, but please note the diversity. We have representatives from all the land-grant colleges in the North Central region, as well as University of Guelph for Ontario. We work with centers of excellence like the Leopold Center, farmer organizations, Practical Farmers of Iowa, and just many different organizations, and that really brings a lot of strength to this network. What is the need? I like to show this chart. The need is really for cover crop information. This is a history of Google searches on the term cover crop, and you can see that cover crop interest in Google searches has been increasing over time. And I really like to point out the sawtooth nature of this curve. If you look closely at it, every one of those peaks is coming in the fall of the year. It's showing that people are looking for cover crops when it's time to plant cover crops, and that's where the interest peaks each year. So there's a need out there. The interest continues to grow. So why do I think Midwest Cover Crop Council is a collaboration that works? Well, I believe part of it is because of the passionate leadership. The people that are involved in the Midwest Cover Crop Council are part of it because they have a passion for cover crops, and they're there because they want to be there. They're not part of it because someone has assigned them to be part of it. And I tell people one of the advantages of our loose collaboration is that we really control who's leading the Midwest Cover Crop Council. We look for passionate leadership. We're an organization where someone is assigning someone to be part of the organization. People come to us because they see the advantages of being part of the council, and it helps them with the work that they do in an area that they have a passion for. It's a very diverse membership. Like I said before, we have scientists and engineers and people from the different agencies, farmer groups, ag industry, and most importantly, we have a large contingent of farmers who are really our stakeholders, who are participating in the Midwest Cover Crop Council, giving us input, helping us identify what their needs are so that we can deliver the products to them. It works because the volunteers really benefit individually. The Midwest Cover Crop Council work integrates with their day-to-day activities. So it's not, in a lot of cases, it's not necessarily a separate task that they have to do to be part of the Midwest Cover Crop Council. It works, integrates very well with things that they're doing on a normal basis. Have an opportunity to leverage a lot of relationships around the region. Within that is a large base of knowledge and solutions. And I have to say there's a lot of trust in the organization. It's a group that where when someone says they'll do something, they do it. And that type of trust to help each other out and to respond to the needs. It's responsive to the growing interest in cover crops. We stay in tune with what's going on. People in the Midwest Cover Crop Council have a lot of contact and meetings with farmers, ag business, and they know what the issues are. We integrate research and education. We do a blend of that with the ultimate goal of producing information for practical solutions. So what do we have to offer to the North Central Region Water Network? We can offer cover crop resources through our website. We have an online cover crop decision tool that farmers and ag consultants can use to help select cover crops. We have produced a Midwest Cover Crop Field Guide. We have an annual meeting, and it also gives you access to cover crop experts through our listserv and an opportunity to collaborate for research, education, and extension. Just some quick stats on some of our products. We have a website. There's over 40 pages of content, over 330 PDF documents. It started in 2008. It's had 120,000 visits since then. Last year, close to 28,000 visits. It's been accessed by a lot of countries, 157 since the beginning. As you would expect, the top countries are U.S., Canada, France, well, U.S. and Canada. But we've also, it's been accessed from France, Germany, the United Kingdom, and India. All 50 states have visited it, and the top states are Illinois, Iowa, Minnesota, Indiana, and Michigan. We have a web-based decision tool to help farmers select cover crops. That was started in 2011, and you can see the number of visits since the beginning and also the last year. We have a field guide, which is now in the second edition. The first edition sold close to 30,000 copies. We released the second edition in September. We rounded out the North Central region by adding Missouri, Kansas, Nebraska, North Dakota, and South Dakota. Some information was updated and some new information added. The first print run was 20,000. That's almost sold out, and we're on the second printing of 20,000 right now. Our next product is to develop that as an iPad application. We hold annual meetings. One annual meeting is held each year within the North Central region. Recently, we've been holding those in conjunction with another cover crop event so that we can leverage more information in a bigger audience. It's a combination of business, technical, education, and practical sessions. It's attended by a diverse audience, and it has a large attendance by farmers. Recently, the attendance has been in the 200 to 300 participant range, and our next meeting will be held in Wisconsin in 2015. Details on that will be coming out here in the near future. We have a listserv, has over 466 subscribers. This gives you access to cover crop experts and users. I'm always amazed when someone poses a question to the listserv. They usually have a response within a couple hours, and usually somewhere 5 to 10 subsequent responses from people around the region that offer advice on what the person is requesting. So that's something you can take advantage of if you join the listserv. It's not one of those junk listservs where you get a whole bunch of stuff you aren't interested in. It usually comes alive when there's a cover crop issue, and then not much happens when there's not a cover crop issue going on. Where are we headed? We've recently gotten some funding from the Walton Family Foundation to establish a home for the Midwest Cover Crop Council and to evaluate and improve our products. We are creating a home for the Midwest Cover Crop Council. It's going to be a program under the agronomy department at Purdue University. We are currently searching for a program manager, so we will have a dedicated resource to the Midwest Cover Crop Council that will be located at Purdue. And we have recently established a new leadership structure that includes a board of directors made up of a representative from each state and province in the Midwest Cover Crop Council, as well as 5 at-large members that come from ag business, regulatory agencies, or farmers. So that's currently where we're headed. We think the future is positive. Continues to be a lot of interest in cover crop resources. So that's what I have.
Great, thank you, Dean. And for those of you that have been involved with the Midwest Cover Crop Council since their inception, you know, or have seen their work and watched them grow, you know what an amazing resource they've been and how much progress they've made over the time that they've been working together. For those of you that have not yet engaged with them, everything that Dean has said is right on. I have to say, with the listserv and having attended their meetings, it's great information, really practical, and you'll be able to use it something right away. So thank you, Dean. And just a reminder, as Janice has said here in the chat box, if you do have questions, Jody, we see your question. You submitted one. I have a question, and for those of you that also have questions, please submit those in the chat box, and we will hold those till the end for all of our presenters. Okay, Tom Kaspar is our next speaker, and Tom is a plant physiologist at USDA Agricultural Research Service at the National Laboratory for Agriculture and the Environment in Ames, Iowa. He has been with ARS since 1981. Over his career, his research has focused on crop and soil management to improve water quality and soil productivity. Since 1990, he has worked on the benefits and management of winter rye as a cover crop in corn and soybean rotations in Iowa. So welcome, Tom, and thank you so much.
Thank you. Well, this is going to be a little different than Dean's presentation. I'm going to talk to you about some research that we've had going on since the fall of 2001. We actually established the field and the tiles in 1999, but as luck would have it, then didn't have enough rain to have any tile drainage in the following year. But the problem we're going to look at is nitrate loss in tile drainage, and as most of you know, agricultural tile drainage is a way to inadvertently short-circuit some of the mechanisms where nitrate is removed from water, because it's transporting water rapidly from fields and doesn't interact with buffers or riparian strips. And as a result, we're moving nitrate into our surface waters and streams. One of the things to keep in mind and why cover crops are an effective approach for managing nitrate loss is because in our normal corn and soybean systems, which make up such a large percentage of the ag cropland in the upper Midwest, we normally have about 5 to 7 months where we don't have living plants out on the landscape. And winter cover crops are a way to get a living plant out there to take up water, nutrients, nitrogen and phosphorus, and protect this topsoil during a time when we normally don't have plants out there. So I realize, yes, that some of this time is frozen, but again, because we don't have plants growing there when it's not frozen, we have a lot of water moving through the soil. The other thing is that, and you'll see from some of the data that we have, that it's not just nitrogen fertilizer. Nitrogen fertilizer management, even if we put on exactly the right amount for corn production, we would still have nitrate losses. So I'm going to talk about an experiment, and if you're seeing my pointer, this is the field that we're working with. We have 24 plots with a tile down the center, and then we're collecting the drainage from each of those plots individually, analyzing it for nitrate and ammonium. This is one of our collection sites. Essentially, we're measuring the flow of water, or the amount of water that's flowing through the tiles, and then each time we have a collection pit at the bottom. Each time that fills up, we pump the water out and we collect a proportional sample for analysis for nitrate and ammonia. And this is just a picture of one of our plots. These are pretty large plots. They're 100 feet wide by 170 feet long. And this is a rye cover crop growing in the middle of April. If I'm remembering correctly, this would have been following a soybean crop, and we'll be planting corn, around the end of April, first part of May. So the first thing I wanted to show you is just what we see in cumulative annual drainage. So what's the amount of drainage that we get over the course of a year. The bluish bars are no cover crop plots, and the reddish bars are where we've had a rye cover crop. The clear bars are the rainfall that we got in those particular years. So it gives you an idea what the proportion of drainage is to our total annual rainfall. The bottom line of this graph over these 12 years is that the cover crop really didn't affect the total amount of drainage by very much, and that was a surprise to us. We thought it would reduce the total amount of drainage. You can see in this far right bars, the average, that it's just a little bit less than the no cover crop treatment. Part of that is that while the cover crop alive, it's using water, so you'd have less drainage during those times, including a lag. And then when the cover crop is dead, it's actually preserving soil water or keeping the soil moisture. So you might have more water preserved and then more drainage during those periods. The other thing to kind of take note of are these 4 years in the middle of the graph, 2007, 2008, 2009, and 2010. Cumulatively over that 4-year period, those were the greatest 4-year total of rainfall that we've had in the climate record in central Iowa. 2008 and 2010 were the second and third wettest years on record. The previous wettest year was, or the number one, was 1993. So essentially it says we've had the greatest, the 1, 2, and 3 greatest rainfall years in the last 20 years. So Whether that's telling us something or not, we'll see in the future. So the bottom line is that cover crops didn't reduce drainage by very much, but this graph, which shows nitrate concentrations in that drainage water, which has been flow weighted, so adjusted for the total flow. Again, the blue bars are the no cover crop bars, the red bars are the where we had a rye cover crop, and this is over the entire drainage year. That over those 12 years, we reduced the nitrate concentration in the drainage by about 60% where we had a cover crop. A couple other things to note with this is that the even-numbered years were the years that we had corn growing, and the odd-number years were soybean years. And we apply all of our nitrogen fertilizer, at least the main nitrogen fertilizer, at planting or within about 3 to 4 weeks after planting. So we're putting some on with a kind of a side dress application at planting, and then the rest of the nitrogen with a side dress usually about 3 to 4 weeks later. A little bit of nitrogen does go on with our P and K source, and I'll talk a little bit about that later. But so one of the high nitrate loss years was 2003, which was a soybean year, and we essentially didn't have any nitrogen applied during the calendar year 2003. Admittedly, some of that is residual nitrogen left over from the 2002 corn year, which was limited by a dry period in August and September. But you can look at 2005, which is also a relatively high nitrate concentration, and 2007, which isn't much different than the two corn years on either side of it. And we know that 2004 and 2006 were above 200 bushels per acre corn yields, and our soil nitrate measurements at the end of the year showed virtually no residual nitrogen. So where's this nitrogen coming from in soybean years? I think we can pretty safely say that quite a bit of it might be coming from mineralization of soil organic matter, and of course whatever residual fertilizer is left over, or nitrogen coming from the decomposition of corn residue. Another thing is, you remember we had those wet years in 2008, 7, 8, 9, and 10. We think this decrease in concentration here is in part due to a flushing or a reduction in the nitrates or ammonia stored in the soil profile. And then here, when we went to somewhat drier years, we're starting to see the concentrations come up, and that continued in 2014. Next, I'm going to show you some data from 2014. Here is the rye cover crop concentration. So these are concentrations taken from our biweekly water samples, depending on the amount of drainage. The blue line is the no cover crop treatment, and the red line is something that we began to add a treatment in 2011. And we're calling this a low nitrogen treatment, but essentially we're not applying any nitrogen to our corn crop on these plots. And we were, the last nitrogen it received was with some phosphorus in the fall of 2011. So here we have a drainage from plots that don't receive any nitrogen, and yet they had a flush of nitrogen in June and late May. And so again, this is kind of evidence that we're getting nitrate or nitrogen coming from soil mineralization. We think that this is really, what in this case is a timing thing. In other words, the timing of when the drainage occurred matched up with, made it come out at that particular time. And also that there's quite a bit of lag in these systems. You know, it can take a long time for the nitrogen to move to the tile. So in any case, again, not just nitrogen fertilizer. So over the 12 years that I've summarized in these graphs, our corn and soybean system lost about 428 pounds per acre. Our corn soybean with rye lost about 191 pounds. So this is load as opposed to concentration, and we had about a 55% reduction in the nitrate load in our tile drainage. And did the cover crop take up enough nitrogen during that time to account for that reduction in nitrate load? And yeah, we can see here that the cover crop over that 12-year period took up about 450 pounds of nitrogen in its shoots, and that's way more than the 237 pounds that we reduced losses in drainage. Do other sites see the same sort of nitrate leaching reduction that we saw at ours? In short, no. These Nashua and Gilmore City are Iowa State sites. They had much lower reductions in nitrate loss. An Iowa State site near Ames, not very far from where we have our site, showed a 36% reduction. And then a farmer in north central Iowa that is part of a monitoring program sponsored by the Iowa Soybean Association and a couple of other entities in Iowa, on the other hand, showed a 48% reduction. But this is probably not surprising that we have differences among sites. The sites have different soils. You're going to get different amounts of cover crop growth depending on when they're planted, how they're managed. All of those things add up to, you know, differences in the reduction in nitrate loss. So I guess in summary, the nitrate losses in the drainage didn't differ much between the corn and soybean years. And some of the nitrate in drainage water comes from soil mineralization, and sometimes it can be quite a bit of it can come from that. Nitrogen management alone won't completely solve nitrate losses in drainage. I guess I'd say that it's probably the first step, or it's the thing that should be considered first. But cover crops can have a place in reducing nitrate losses, as do some of the other practices like buffers and filter strips along streams. Wetlands too. And then lastly, growing a cover crop during that period between maturity and planting of corn and soybean crops, I think can definitely reduce nitrate losses. And that's all I have.
Great, thank you, Tom. That's all. That's a lot, so we appreciate it very much. And again, a reminder to people to, if you have questions for Tom, please submit them in the chat box, and we'll continue to collect those until after Matt's presentation. So Matt Ruark is our next speaker, and Matt is an assistant professor in the Department of Soil Science at the University of Wisconsin-Madison and an extension specialist in the University of Wisconsin Extension. He runs a fully integrated extension and research program related to nutrient management and nutrient cycling in agroecosystems. You can read the research priorities of his lab there, improving the understanding of carbon and nitrogen cycling in dairy production systems, being in Wisconsin, of course, evaluating nitrogen fertilizer sources across different soil types and cropping systems to improve production and use efficiency while reducing impacts to surface and groundwater, assessing the role of soil physics and biological measurement for use in nutrient management planning, and evaluating the benefits of cover crops for crop production and soil health. He serves as a faculty advisor to our Unibeard Discovery Farms program, and the Wisconsin Agribusiness Association serves on the executive committee of the Midwest Cover Crop Council, and is an associated editor for Agronomy Journal and a project director for a $10 million NIFA AFRI-CAP grant on mitigation of greenhouse gas emissions and adaptation of climate change in dairy production systems. So truly a systems guy. Thanks, Matt, and go ahead.
Well, I didn't mean to make you read all of that, and I guess I should update it. I am a former executive committee member of the Midwest Cover Crop Council. So what I thought I'd talk about today, get into a specific scenario where so I live and work in Wisconsin, got a lot of dairy production. We have fall manure application that occurs. Is there a role, what's the role of cover crops in improving the sustainability of dairy systems that have this fall application? I just want to acknowledge some of my collaborators, Jamie West and Kevin Shelley, who've been running a lot of these trials as well. So when I talk about fall manure, the first thing is that it's going to happen, right? We're in a spot where there's some restricted soils that won't allow fall manure application, but for the most part, it's going to happen. So how can we integrate cover crops into these systems? We know that with fall manure application, that'll increase losses, especially on tiled drains. There's some data out of Indiana, out of an 8-year study. We see that this is a swine manure application, but fall swine manure, we'll get this over here. So fall swine manure had about twice, this is the nitrate-nitrogen concentration, average concentration in the tile drain. Basically doubled it compared to a spring application or compared to a spring application of UAN. So we know a fall manure, we lose efficiency with applying manure in the fall. This is just reiterating some of Tom's data that he presented, but on a 5-year study, without a cover crop, the average nitrate concentration was about 12. This is not include a manure application, but when you put a cover crop, it reduces nitrate in the tile drain. Like Tom said, it's part of the solution. So we have an issue where we know we're not efficient with manure in the fall. We know cover crops can reduce nitrate in the tile drains. So can we start using more cover crops to try to control some of that nitrate loss in these fall manure systems? All right, so I'm going to talk about two different studies, but both located at the same portion. So right there in south central Wisconsin at our Arlington Ag Research Station, it's on a Plano silt loam. Similar soils that extend into Iowa and Illinois as well. So this is our study location. So our first study was relatively simple. It's a continuous corn silage production system that after corn silage harvest in early September receives an application of liquid dairy manure of about 8,000 gallons per acre. Then we either do not plant a cover crop, or we plant winter rye that's terminated in the spring. So winter rye is a cover crop, or we plant winter rye as a silage crop, something that we harvest in that spring as well. So here's what the field would look like in the spring of the year. So we're waiting for this rye silage to grow a little bit more before we harvest it, but this right after the winter rye has been sprayed, so we do have it terminated there. So what we've noticed, we've done this for 3 consecutive years now. It's basically a tale of 2 seasons. So in our first spring that we did this in 2012, We had a lot of biomass, a really early spring, really warm spring. It warmed up, we got a lot of biomass. And this is maybe a little bit more than we would want, but we had 115 pounds of nitrogen taken up in that rye biomass. So this is that rye cover crop. But in the other 2 years, in 2013, 2014, that rye biomass and the above ground biomass portion only took up about 11 pounds of nitrogen. But it did provide good cover. Now you compare that to where you're going to let that grow and make it, it's not necessarily a cover crop at that point, it's an additional silage crop. You let it grow a little bit more, a couple extra weeks, and now if we go back, so we're looking at 125, 73, 65 pounds of nitrogen in any 1 year taken up in that biomass. So one thing to note, so this is when we let, like we'll take 2013 for example, this RYELAGE crop we let grow to into mid-May here, May 21st. On the previous slide, you notice we harvest this on May 1st. So basically in that 21 days, whenever that heat kicks in, you have all that growth. So managing it as a cover crop can be tricky because once it starts to take off, it can really grow quickly in the spring. But once we do that, we know it starts taking up more nitrogen, and so the question is that what we want? So we don't, this location is not tile drained. We have more groundwater nitrate issues in this region. And so we're going to use measures of pre-plant nitrate to be sort of a de facto measurement of water quality, where we're looking for this. We're looking for, did the rye cover crop reduce spring nitrate, the nitrate in the soil at planting? And certainly in 2012, it reduced it, and in the light blue, that's in the first foot, and the dark blue, that's in the second foot. So in 2012, the cover crop actually reduced it across 2 feet, in the 2 feet depth. But in 2013 and 2014, where we didn't have as much growth, we only had didn't have as much biomass, only 11 pounds of nitrogen taken up. We only saw that reduction with that adding that cover crop in that first foot. There wasn't really a difference in that second foot, and a very similar thing in 2014 as well. So it does reduce soil nitrate. It does do what we want it to do, but it always reduces it in the 0 to 1 inch, 1 foot depth, but not in that second foot. So for that, we have to let that biomass grow longer, and then we start to get a trade-off between cover crop for nitrate and erosion control as opposed to compared to production. So what we have here is then we also then grew that corn silage crop after the cover crop was terminated or the silage crop was harvested, and we did it across 3 different nitrogen rates. And the main thing that I want to show here is that the cover crop did not reduce yields, and this is data from 2012. But so in the greenish blue circles, that's corn silage following rye as a cover crop, and in the squares there was no cover crop. So we can see at all the nitrogen rates, there was not a big difference in yield, and in fact there wasn't a yield reduction by growing that cover crop. So we hear some concerns that will the rye decrease my corn yield? Well, in corn silage yields, in this study, in 2 or 3 years, or in all of the years, the cover crop did not reduce the corn silage yield. When you let that rye grow, and you can see here where we take that rye off as RYELAGE, that subsequent corn silage yield was decreased. And that was pretty consistent across years, that there was a yield decrease in that scenario. However, I have these arrows here pointing up because in this situation, we've actually produced more RYELAGE. So we produced additional silage as well. So when you add it together, and you look up here, this is the total forage or total silage produced is corn silage and RYELAGE. So in 2 to 3 years, we were up significantly on total biomass produced. So, so that's that study. We're going to keep continuing that study to evaluate differences in soil quality and soil health over time by having a cover crop being grown compared to not in those systems. We have other studies that we wanted to expand upon this research. So in 2014, we started a project where at 5 locations throughout Wisconsin, we put out basically a similar study where we have corn silage harvest, and then a fall manure application, and then we plant cover crops. And we did this at 5 locations. I'll show you some pictures of what happened at our Arlington station. And so, and this is from this past year, so 2014. So here's what winter rye looked like. You know, we got some. This is in November, so we did get some growth, not as much cover as we'd like, but when you look down on top of it, it looks pretty good. We compare winter rye to triticale. A little bit better growth, a little bit more growth with the triticale in terms of coverage, but not too dissimilar. Now, triticale will survive the winters in Wisconsin. One that will not will be spring barley, and this is another one that we wanted to study the effects of, because if farmers are concerned with having to go out and spray a cover crop or manage a cover crop in the spring, can we get any benefit? Do we get the same benefit by growing a cover crop that will winter kill? So in Wisconsin, two popular ones would be spring barley or oats. Now we like spring barley because it's said to grow quicker, and we've seen it have a faster growth in the fall compared to winter rye. And in this study too, we see that there was a little bit difference in the growth compared to the winter rye. So this was the most biomass that we produced just in that fall time period, basically between September and November, was the spring barley. Another one we evaluated was annual rye grass. So this is sold and marketed or promoted and for having greater soil building benefit than winter rye alone. Now, we did not see as good of a growth at this location in 2014, although it did survive the winter, but we didn't have a lot of regrowth in the spring either. So at this point with annual rye grass, in Wisconsin, it just could be we probably don't have, if there is any advantage over ryegrass over rye, it's possible that we just don't have enough growing season for those benefits to be realized. But we will continue that work. So some data then from last winter. So we took soil samples in November of 2014, and we've got all of our treatments in here. So this is our starting nitrate, soil nitrate when before we planted the manure or the cover crops. Here's our control. That means no cover crop and no manure. So and this is collected in November. So this would be the regular background nitrate without any manure or a cover crop. Nope, with manure application and no cover crop, we see we have an increase in the soil nitrate in the fall, as we'd expect. We applied a lot of nitrate or a lot of organic nitrogen that mineralizes quickly with the manure. But we've got all the cover crop treatments here. So winter rye, triticale, and spring barley all reduced the soil nitrate, especially in that first foot in that winter growing season. The annual rye grass, ARG, we didn't have as much growth, and therefore we didn't have as much nitrate uptake, and we had more nitrate left in the soil at that time. So we continue into the spring. So this soil samples were collected in late April, and we see the winter rye, which continued to grow in the spring, continued to reduce soil nitrate compared to the no cover crop control. The spring barley still had lower nitrate in that soil compared to the no cover crop, but it stopped growing in the spring. So we don't have that continued growth in the spring to help take up any excess nitrate that would occur. And the annual ryegrass did not perform well. So this is very preliminary data. We plan on continuing this research for several years. And we have it at multiple locations on different soil types throughout the state of Wisconsin. So in Wisconsin, we've got a lot of dairy, we've got a lot of corn silage. So it really works. This is a system that really can work well for Wisconsin because we have that time for those cover crops to grow. We can get them planted in September. So with that, I'll leave you with a few conclusions. But the winter rye as a cover did not affect corn silage yield. Winter rye as a forage crop did decrease the nitrogen balance or improve the nitrogen balance because there's a lot more nitrogen removal from the system, but it may result in a decrease in corn silage yield. So, but overall, we can produce more silage, but if you want to produce the corn silage, there's a risk of reducing some of that yield. We really like spring barley for those farmers who don't want to have to kill anything in the spring. It does seem to have a bit faster growth and can put on more biomass in the fall. But again, that winter rye, because it grows again in the spring, will have more total biomass and probably have more of a water quality benefit. And then the real reason for all of this work is how is this affecting our nitrogen management that next year? How much nitrogen should we be applying to these crops? So are those cover crops taking up just the nitrate from the manure that was going to leach anyway? Or are we taking up some of that nitrogen and actually there's less nitrogen from that manure to be available to that next crop? So how are we affecting the overall nitrogen requirements for that subsequent crop when growing these cover crops? So this is the first year we've planted corn. We have different nitrogen rates to determine that effect. So that's the future of the research in Wisconsin in these systems. So with that, I'll end it and turn it back over to the moderators.
Great, thanks, Matt. Okay, great series of presentations. Let's go back up to some questions here. So Jody had our first question. How come Missouri is not in your online tools for the Midwest Cover Crop Council? And Dean, that question is probably for you.
We've been talking with Missouri for quite a while about creating that tool. Like I said, we don't have any permanent, real permanent funding for the Midwest Cover Crop Council. So one of the things we do ask is each state to kick in some dollars for the creation of tools specifically for their state. And currently, I think there's been a little bit of a struggle getting that together in Missouri. They're on the list. We'd like to get them going. I hope to get them involved here in the near future. Just so everybody knows, the next state we are currently working on is Kansas.
Great, thanks, Dean. And I see we have some participants from Missouri, so glad to see you all on. I had a question for you, Dean, about the 2015 meeting. I know you said more information will be coming soon, but do you have dates set for the meeting yet?
We usually hold the meeting in February. Seems to be about the best time, and we dodge things like Moses, try to dodge things like Moses and the Ohio Conservation Tillage Conference and some things like that. We don't have the definite dates yet, and actually Matt is the one who's working on that one. I don't know if he's got anything to offer at this point. Matt?
We're working on it.
Okay.
We'll get it. We'll get something put together in the next month or two. But we are planning on hosting it in Madison in 2016.
Great. Okay, so that's a 2016 date.
I'm sorry, I put that wrong on the slide. That's actually 2016.
Got it. Spring was our first clue. Okay. Thank you. Let's see. Here we go. Gene Schreifer. He says, checked the field this morning. That was no-till corn into killed cereal rye. He said lots of armyworm feeding there. Is this an annual issue or just more frequent with cover crops?
Well, I can try to deal with that. This is Tom, and first off, I don't know a whole lot about armyworm. I have heard of that occurring before. It seems to be more of an issue this spring than it usually is. I guess another part of it is, especially with corn, our usual recommendation would be to have the cover crop sprayed 10 to 14 days before we plant corn. So in a lot of years, the cover crop is going to be dead by the time the corn comes up, and I would think but I don't know that that would help to reduce the problem. Because armyworm is a moth coming up from the south, you know, this is one of those things that if it continues to be an issue, that we would be able to at least have an idea when the moths are flying, and if that becomes a concern, then that would, you'd want to spray the cover crops at that time, or at least scout for those worms. But yeah, I'm not an entomologist. I've never had a problem with that myself, but I have heard reports, especially this spring, of that being an issue.
Matt or Dean, anything to add?
This is Dean. No.
No.
Okay, all right. And a perennial question, Matt, how are you measuring soil health?
Okay, good question, and I have it in there as a bit of a catch-all. But what I'm really interested in is how can we use these other measurements to help improve our understanding of how much nitrogen will be supplied by the soil. So we're really interested in three things. One is soil aggregation. So we want what management practices can we use to promote or can we use that will build macro aggregates. And it's this concept that leads to more carbon and nitrogen storage if it's physically protected. So one thing I'm very interested in is measuring it in terms of soil aggregation. The second thing is also some measurements of mineralizable nitrogen, and there's a method that we use, and the output is potentially mineralizable nitrogen. Have we done anything through crop rotation, tillage, use of cover crops that will increase the nitrogen supply from the soil? So we do. We're evaluating that right now in our Wisconsin. We've got some systems now that have been in place for 20+ years, and now we can start. We start with the same soil, we manage it differently for 20+ years, and we can evaluate how we've affected it. These cover crop studies, I think they need to go for longer periods of time. So we just now have a few ones that they're in their 4th or 5th year where we can start to potentially evaluate differences in nitrogen supply from the soil. So those are two, and then the third one is water holding capacity. So which ties into some with the aggregation, but have we built up the soil organic matter as well, in a way where we can store more water in the soil and maybe mitigate some stresses later in the growing season. So that's sort of the angle I'm talking about with when I throw out that catch-all of soil health.
Okay, thank you. And then from Jean again, is there a difference in kill then plant versus plant then kill? You know, can a producer plant first and then kill the cover crop?
Well, this is Tom again. A lot of people, especially farmers, have been doing it a lot of different ways. I do know of farmers that, especially with planting soybeans into cereal rye, have planted into living cereal rye and then killed it. We don't normally recommend that with corn, but I'm aware of people that have done that. You know, you start to, depending on how big the cereal rye is, start to get into some issues with planter performance, but people that have experience with it seem to be able to handle that. With corn, we usually don't recommend that because of issues with things, for example, like the armyworms, but I'm not sure that maybe if they still had the rye to grow or to feed on, maybe it wouldn't be as big of an issue, but I don't know that. I don't know about the armyworms.
Thanks, Tom. I'm just going to get to these last couple questions here real quick.
Me. I got a, Rebecca. One thing to check if you're considering that is crop insurance regulations. They have some regulations as far as how long after planting you need to terminate the cover crop.
Good point, Dean. Yep.
Yep, very good point. Thanks for that. Let's get Jody, the contact person for Missouri, for the Cover Crop Council or a cover crop contact.
Yeah, the representative from Missouri is Rich Horman from the University of Missouri Extension.
Great, thank you. And then Matt, can you say anything quickly here about the method of manure application that you used and what impact it had on the stand-up cover?
Yeah, we did everything was injected. It was a liquid manure injection, and then we went through and drilled in the cover crop. So very straightforward method. The cover crop establishment was pretty good, so it wasn't, there's no destruction. There's others that are researching the flip side of that, getting that cover crop established first and then putting the manure on. That's probably the next thing that needs some extensive work.
Thank you. That was great. Thank you. Here's the contact information for Dean, Tom, and Matt on your screen. Thank you so much to all of our speakers. And just again want to remind you that the next North Central Region Water Network webinar is July 15th at 2 p.m. Central, 3 p.m. Eastern, and it's going to be all about harmful algal blooms. So thanks so much for joining us today, and we look forward to seeing you again maybe sometime in the future. Have a good afternoon.